Okay, so we're going to start this discussion with what are atoms. And a caveat on this is I've tried to distill this lecture down to the bare minimum that you need for biology. If you've had chemistry, and I know many of you have, there's some things on here that you might think, oh, I've heard about that in chemistry, and that's true. But I've tried to pull it down to the bare essentials. So you can move forward in later chapters and have what you need to understand those concepts. So let's begin. So why? Why are atoms important? Why is this important? Okay. Well, we're going to see these concepts later on. For example, photosynthesis. In photosynthesis, we're going to see how water, being H2O, how that breaks down into protons, electrons, and ultimately oxygen. To describe how oxygen is released from a plant, you have to understand how atoms work and how electrons and protons come off. Metabolism, when we start talking about ATP, okay, we'll talk more about that later on. You don't understand ATP without understanding what a proton is. How macromolecules behave. Why is it that you put oil in water and it doesn't mix, whereas you put ethanol in water and you got a mixed drink? Why does that behave like that? Again, it all goes back to this basic atomic model. Okay, so that's why we have to cover it, because it is important to talk about these types of concepts moving forward. So atoms, obviously, pretty much already know this, are the building blocks of all substances. And they're made of 3 subatomic particles. We have the electrons, shown here. This is the electron, and this is the electron here. And then we have a core made of protons and neutrons, shown here. Now, we're going to talk a little bit more about this in another video following this. But you should know this basic model. All right? Now, these pictures are not drawn to scale. These are one of those little things that we make it this way because we want to describe it in the format you're seeing. In actuality, the electron is far, far smaller than the proton and neutron, and the distance between the two is far greater than shown here. Okay, so again, we're going to do this type of diagram many times in the semester, but don't take this as an exact model of how it is. Okay. Also, do we see how the electron's path, this orbital, is in a circular motion? Well, sometimes, you can do things like shapes like this and like this. There's many different types of shapes. All right. So we'll talk more about that later on. So let's start with the basic model here. In the center, we have what? We have the subatomic particles of protons. And I'm going to use green to represent a proton. So this is 1 proton, 2, 3, 4, 5, 6. So I have 6 protons here. Now, the number of protons defines what an atom is. So what do I mean by that? Well, all carbon atoms will have 6 protons. All hydrogen atoms will have 1 proton. All helium atoms will have 2 protons. There's no variation in this. You change the number of protons, you change what you call an atom. Also, protons have a positive 1 charge. Okay, we've given it a number, and we say that it has a positive charge. Okay, somewhat of an arbitrary term, and we've given it this arbitrary value of +1. Now, we're going to see these later on in the semester where we build a proton gradient. Okay, these are going to move through ATP synthetase, and it will help form ATP. Now, we'll get into this in a few weeks, maybe even over a month. But when we talk about protons later on, this is what we are talking about. In addition to the protons, we will almost always see neutrons. Okay, so I'm going to draw 6 here. 3, 4, 5, 6. Okay, and I chose my words very carefully on that one. All right, here I say we almost always see neutrons. We'll always see neutrons in a nucleus except for one situation, and that is a case of one isotope of hydrogen, okay, that only has a proton. Barring that one exception, all other atoms will have one or more neutrons. Here I've drawn 6 neutrons, and we say that neutrons have a 0 charge. Okay, they don't contribute to the charge of an atom. They're about the same mass as a proton, and they're found in the nucleus of an atom. Now, neutron number can vary. So, for example, here I've drawn 6 neutrons. Okay, and we have 6 protons, and we have what we call carbon-12. But there could also be in some atoms of carbon another two neutrons, and that would be carbon-14. All right, those are isotopes of carbon. So when neutron number varies, we have isotopes. And we'll talk about isotopes with radioactive dating later on, but for the most part, we're really not going to talk all that much about what a neutron is. Now, in addition to this, we have electrons surrounding this nucleus. Now, these electrons are negatively charged, and we have given it a -1 charge. So it's the same magnitude of charge as a proton, but it is of the opposite charge. Okay, this is somewhat of an arbitrary term, but we're just going to say for the purposes of this class that it has a negative charge, which is an opposite charge to the proton, and it is of the same size charge. So if one is +1, the other one is -1. Okay. So electrons are going at a very high rate of speed around the nucleus, and it's going so fast that it forms almost like a shell surrounding it. Okay, it's going so fast that all of these electrons form almost like a physical construct around the nucleus. I've always thought of it as a ceiling fan, right? Think about a ceiling fan that is on. Do you perceive the individual blades? Well, not really, because it almost looks like a whirling disc, a blurry disc of motion, right? Made up of the blades. Or a propeller to a plane, do you see the individual propellers? Or to a helicopter, do you see the individual blades? No, you don't. You just see a zone of motion, right? Because they're going so fast that you really don't think of them as individual blades. You think of it as a zone of motion. All right, same thing with the electron, that these are going so fast around the nucleus that it almost forms a cloud of sorts around our atom. All right, and this motion of electrons is very important because electrons can do some things. What kind of things? Sometimes an electron can leave. Depends on the atom and the situation, but sometimes an electron can leave. Okay? Its presence is not quote-unquote good, so it can leave. Sometimes an electron can enter an atom or become part of an atom. Okay? Different situations, sometimes that will happen. Sometimes an electron can be shared between 2 atoms. All right? So we can have electrons becoming part of an atom, we can have electrons leaving an atom, and we can have the sharing of electrons. And this concept becomes really important later on. So to review, 1, atoms are made of 3 subatomic particles. We have the protons and the neutrons, and those are in the center. We have the electrons. Those are in constant motion surrounding that nucleus. We also said that electrons have a -1 charge, and the protons have a +1 charge.